Good morning, class. This is your teacher speaking, and we are ready for a takeoff into multiplying radicals. Little joke to start off because I was told I sound like a pilot on these videos talking to their passengers. So, yeah, there we go. All right, so we're moving on with radicals, and today we are going to be looking at multiplying and dividing the radicals. So, first off, remember that in our radical, we have this right here. The number that is in there is called the index. The value under here is called the radicand. And then we have our radical symbol right there. Okay, so first of all radicals must have the same index in order for you to be able to multiply them. And when you are multiplying them, there's going to be values on the outside of the radical, and then our radicand, the values on the inside of the radical. So multiplying base numbers as usual, okay? So, if you have 2 times 2, then you would get 4. But the thing is that you have to multiply outside values with outside and inside values with inside. So we are going to be relying on the properties of multiplying exponents. And what happens when we multiply exponents? For instance, if you have x to the fourth times x to the third, what do we do with those? Anyone? Anyone? All right, yes, we do add them. Whoops, left my highlighter on. All right, so we are going to add them together. We add the exponents. Then we will simplify from there, and we will use our rules that we did yesterday. Okay, so once again, outside values get multiplied together and the inside values get multiplied together. So when we do that, what is 2 times 5? 10. What is 3 times 18? 54. And then we're going to simplify that. So outside with outside, inside with inside. So outside, inside. So we haven't dealt with the exponents yet, but then we're going to simplify that. So we need to simplify the square root of 54 as we normally would. So scroll this up a little bit. There we go. Okay, so we're going to break down 54. So that'd be 2 times 27. 3 times 9. And 3 times 3. So we should be okay with simplifying these now really at this point. So one of the 3's will come out, the 2 and the 3 will stay in. So when that comes out, that is going to make this, that 10 was already there, the 3, so we're taking the square root of 3 squared, so that comes out as 3. And then we have this 2 times 3 left inside, so that is going to give us a 6. Now we have these values both outside. Those can be multiplied, so I get 30 square root 6. All right. Okay, problem 2. This is where the multiplying of our exponents comes into play. So the x can be multiplied with the x, the y's with the y's, and those exponents are going to get added. So when I multiply those, I get x to the 10th, y to the 6th, and then I simplify as normal. So once again, index is 2, so I'm dividing these by a 2. So I get x to the 5th, y to the 3rd. All right, now let's put them together. Now notice this one, I have cube roots here. Okay, same rules apply. Anything outside can be multiplied together, and anything inside can be multiplied together. It doesn't change just because the index changes, but because the indexes are the same, it makes these possible to multiply. So outside, there's nothing else outside, so I'm going to leave that 5. Then I have the 3rd root, 8 times 10, that's 80, a to the 8th. And now we're going to break this down. So 80, that's 2 times 40, 2 times 20, 2 times 10, 2 times 5. So when I simplify this, I have 5 cube root of 2 to the 4th. Well, actually, let me redo that because you need something divisible by 3, remember. So what I have is I do have 2 to the 4th, 1, 2, 3, 4, but I'm going to want to write that as 2 to the 3rd. times 2 times 5. So that still is 2, 1, 2, 3, 4 2s. That's 4 2s and 1 5. And then my a to the 8th needs to be divisible by 3. So what's the number underneath 8 divisible by 3? A 6. And that leaves us with a squared there. Okay, so I'm going to bring out. What can I bring out? Well, I can simplify this, and I can simplify this. So I can bring out a 2 and an a to the 2nd. And what stays in is the 2 times 5, so 10, and a squared. So my final answer is 10a squared cube root of 10a squared. How about that? 10a squared cube root of 10a squared. All right, this one's a little bit longer, but same process. Outside with outside, inside with inside. All right, so we have 30 square root of 15 times 5, 75, x to the 8th, y to the 7th, z to the 6th. We're going to want to break down anything that's divisible by 2. So 75, I'm going to do that off to the side here. That's 3 times 25, 5 times 5. All right, so I have 3 times 5 squared. The x to the 8th is divisible, so I'm going to leave it, x to the 8th. Y to the 7th needs to become y to the 6th, y, and z to the 6th is fine. Why is that fine? Because those are divisible by 2. So any exponent divisible by a 2 can be divided. Okie dokie. So the 30 is still there. But what's going to join that 30 is a 5, an x to the 4th, y to the 3rd, z to the 3rd. I wrote a 6, I'm going to change that. Oh no, I just got rid of, accidentally erased, what did I erase there? I erased the y, whoops, on accident. Put that back in there. Okay, so z to the 3rd. Now I just need to clean that up a little bit. So 30 times 5, that's 150, x to the 4th, y to the 3rd, z to the 3rd. There's our answer. All right, so that's multiplication. Outside with outside, inside with inside, and simplify just as we did yesterday. So now we're going to move on to division. All right, so division. Let's read our little sayings here. All right, so as we know, we may not have a radical and a denominator. So we are going to have to rationalize this denominator. This means that we need to multiply the numerator and denominator by a value that will make the denominator a perfect root. Okay, now there's some things with the division. Okay, these first two actually are not too bad because there's some things that you can do here. Okay, even though these are two separate radicals, it is okay to make them one radical. And what is 27 divided by 3? It's 9. All right, so we have the square root of 9. What's the square root of 9? 3. And we actually don't need to rationalize it because there's no radical even left. So the only time we have to rationalize the denominator is if there's a radical in the denominator after we've tried to simplify. All right, so we had two separate radicals. We can make those one and divide and simplify. The other thing that's not too bad is if, say there's one radical but in one fraction. Now, 12 is divisible by 3, 4 is not divisible by 3. But the great thing about this is you can, again, just go ahead and actually divide them. Remember, when we're dividing exponents, or dividing values that contain exponents, what do we do with those exponents? Subtract. So we are going to subtract those two guys, and that gives me x to the 8th power. Well, I have the cube root of that. Okay, there's no radical in the denominator. We do, however, still want to simplify that, though. Okay, so what's the value underneath 8 that's divisible by 3? A 6. So we end up with x squared cube root of x squared. is how that's going to divide. Okay, again, because I just actually subtracted those exponents. That's the rules of division of exponents. Okay, now, what if we can't divide? What if we can't divide it at all? And we have radicals left. That's where the rationalization comes in. Okay, so even if you can't divide these. You can't divide an x with a y. And I have a radical here in the denominator, so this needs to be rationalized. You cannot leave a radical in the denominator. So what we are going to do now is multiply it by something that will make it a perfect radical. What's going to make a cube root become a perfect radical is when you have an exponent that's divisible by the 3. I have an x to the first power right now. So I need a value that's going to make this divisible by 3. Well, what's the number bigger than 1 that's divisible by 3 is a 3. So I have 1y right here. How many more do I need to make it a 3? 2. So that means I need to multiply both the numerator and denominator by the cube root of y squared. The reason we can do this is because what is this equivalent to? It's equivalent to 1. And when we multiply anything by 1, it doesn't change the problem. Okay, so now we'll go through and now apply our multiplying rules. X to the 10th times y squared is x to the 10th times y squared. Cube root, what's in the denominator? Y to the 3rd. And now we're going to simplify these. I need exponents that are divisible by 3. Okay, so I can now change this to make it, change it to where it's a cube root of x to the 9th x. I can't do anything with that y squared. Okay, we're not going to add in anything because I already rationalized that. And the cube root of y to the 3rd is already good to go. So we'll simplify it. Cube root of y to the 9th is x to the 3rd. Cube root of x, y squared. And what's the cube root of y to the 3rd? Y. That's your answer. All right, last little bit. We have a square root, and neither of these are, you can't divide either of these. So now what I need to do is multiply it by a square root. That makes these perfect squares. So 3 times 3. That would make that a perfect square. I have y to the 9th. What's the next number that's going to be divisible by 2? A 10. Okay, so how many more do I actually need to actually add in there? Whoops, got rid of my radical. Wasn't supposed to do that. You need only one y. That's going to make this y to the 10th. So then you have y. All right, so I end up with 24 x to the 7th y divided by the square root of 9y to the 10th. And we simplify everything we can. All right, 24. That's 2 times 12, 2 times 6, 2 times 3. Okay, so that means that that's going to be 2 squared times 2 times 3. X to the 6th x, y. So again, I want values that are divisible by 2. Square root of 9y to the 10th. That one's already set up to go. All right, so now I'm going through the process of simplifying. Divide these by 2. Well, the square root of 9 is 9, but you can write it as 3 squared if you would like. Or square root of 9 is 3, but you can write it as 3 squared. So my final answer, 2 x to the 3rd square root 6x y divided by 3 y to the 5th power. That is our final answer. All right, and I know yesterday's video I made a mistake. Hopefully I did not make any mistakes in this one, but I hope you have a great day. Please, please, please email me if you have questions and you want to set up a live classroom and we can go through some problems. Okay, we will see you later.